When we talk about perimeter and area of composite shapes, composite just means more than one shape at a time. So it's really like doing multiple problems in the same one. Just as a reminder, to find the perimeter of any shape, you need to add up all the sides. And then reminder of all your area formulas, because most of the time it actually asks for area. If you see a rectangle or a square or a parallelogram or anything like that, it is the base times the height. If you see a triangle, it is 1/2 the base times the height. And then if you see a circle, it is pi r squared. And remember that sometimes you use pi and sometimes you use 3.14. Check out what the answer choices are in. So if you see shapes that are put together, as in they're sitting next to each other, you can add their areas. If you see shapes that are cut out of other shapes, you can subtract their areas. It's pretty straightforward when you do this. So in these three examples here, it says find the area of each shape. And what you need to do is you need to imagine cutting these shapes up. So here I see a big rectangle and a small rectangle. Here they already kind of made the cut for us. I see a rectangle and 1/2 of a circle. Here, if I cut it here, I see a square and a triangle. So we're really just finding the area of each shape individually and adding them together. So for this one, this rectangle, it is the area is the base times the height. Well, the base has to be 6 because it has to match the top times 7 for the height, which is 42. For this little one right here, the base times the height, they're both 4. So 4 times 4 is 16. And then I need to add these two areas together because I'm combining them. And so together that makes a total of 58 inches squared for the area. So it's really just finding the area of each piece individually. For this one, I noticed that it doesn't actually give me the height, but it does tell me that the radius of this circle is 8. So this piece must be 8, and this piece must also be 8. So the height of this one must be 16. So let's do the square first, or the rectangle first. So 23 times 16, which is 368. That's just calculator magic. Over here, it's pi r squared for the whole circle, which is pi times 8 squared. And I'm going to go ahead and use the 3.14 for this one. 3.14 times 8 squared is 200.96, but this isn't actually a whole circle. It's only half of a circle. So I'm going to divide it by 2 to get 100.48. And then we're going to add those two areas together to get 468.48 feet squared. Area is always in units squared. All right, for the last one, let's start with the square. The area of the square is going to be 20 times 20, base times height, which is 400. The area of the triangle is going to be 1/2 times the base, and I'm actually going to think of this being kind of on its side. The base here is 20, so 1/2 times 20 times, and then the height, it tells us 10. So 1/2 times 20 times 10 is 100, giving us the nice, neat 500 meters squared for the total area. The ones beneath here are the cutouts, right? Find the shaded area of each shape. So if I look, there's actually 2 shapes in each of these guys, right? The big shape here is the square. So the area of the square is going to be 10 times 10. Because it's a square, so the base is 10, the height is 10, so the total area is 100. If I look at the circle on the inside, I notice that here's the center to the edge. Well, if the whole thing is 10, then half of it must be 5. So the area of the circle is pi r squared. And that pi times 5 squared, using the 3.14, is 78.5. And in this case, I'm not adding them together. They're not next to each other. What I did was I took this square and I cut out the circle. So this guy is actually a subtraction problem. 100 minus the 78.5 is 21.5. And it doesn't tell us what the measurements are, so I'm just going to use units squared. So you just do the big shape minus the small shape. Here, you'll notice this is really similar, but in this case, it actually gives us the reverse. The circle is the big shape, and then the square is the cutout. So the area of the circle is pi times 12 squared. The radius, it tells us, is 12, which is 144 times 3.14 is 452.16. The area of the square is a little bit harder. Now, it doesn't give us this side length. So what I actually did was I cut this up into triangles. So here, I know this is 12, so this is also 12. So the base is 24. And then the height is another radius, so that must also be 12. So the area of the triangle was 1/2 times the 24 times the 12. Which is 144, but notice that there's a triangle over here and another triangle over here. So the total area is 288. 144, but then you have to double it to get the two triangles. And this time I'm taking the circle and cutting out the square. So 452.16 minus 288 is 164.16 meters squared. The last one is actually two triangles. I have a big triangle, and then I cut off this little tip of a triangle at the end. So for the big triangle, it's 1/2 times the base times the height. 1/2 times 8 times 6 is 24. For the little triangle, I noticed that it doesn't actually give it this, but it does give us these tick marks. And if you remember from geometry last year, those tick marks mean they are the same length. So if the whole thing is 8 and they're both the same length, this must be 4. So the area of the tiny triangle is 1/2 times the 4 times the 3, which is 6. And again, I'm cutting it out, so I'm subtracting. So that gives me a total of 18 centimeters squared.